Hello students, welcome back to my channel Explore Physics, Let's Explore. Hope you all are doing fine. In the previous class, if you recollect, I've explained you about the ray diagrams or the image formation by spherical lenses. Today I'm going to explain you about the sign convention for lenses, lens formula, magnification and power of lenses. So without further delay, let's start the class. So the sign convention for lenses. It's somewhat the same what we have discussed for mirror. The only difference is that the measurements which we are going to take for lenses, we are going to start or we are going to take it from optical center. If you recollect for the mirrors, we were supposed to take the measurements from the pole. Now in the case of lenses, we are going to start measuring the distances from the optical center, the O optical center of the lens. It's the same, the direction of incident ray is taken to be positive and opposite to that negative. So incident ray's direction is taken to be positive, opposite to that is taken to be negative. All the measurements above the principal axis are taken as positive and below the principal axis are taken to be negative. Actually, we follow here the sign of distances. The rules are same as for the sign of distances. So what did I tell you? We are going to take the measurements from optical center, that is 1. All the measurements are taken positive along the direction of incident ray and opposite to that it's negative. Above the principal axis all the measurements are taken as positive and below the principal axis they are taken as negative. So this is all about the sign convention for lenses. Like we have discussed for concave mirrors and convex mirrors, plus and x and minus x, plus y and minus y axis, it's the same thing. Incident ray plus x-axis, that is positive direction. Minus x-axis, that is negative direction. Above principal axis plus y, that is positive. Above principal axis, positive measurements. Below principal axis, that is minus y-axis, that are minus directions we are going to take. We are going to take the measurements from the optical center. So this is all about the sign convention for lenses. Now what is this lens formula? Remember we have discussed for the case of mirror formula. Now we have the lens formula. And what does it say? What is that? It is 1 upon f is equal to 1 upon v minus 1 upon u, where f is the focal length, v is the distance between the image and the lens, and u is the distance between the object and the lens. If you remember, for mirror, the sign here was positive. Mirror formula was 1 upon f is equal to 1 upon v plus 1 upon u. Here, for lenses, we have 1 upon f is equal to 1 upon v minus 1 upon u. So, just remember that. And magnification, to which extent the image is magnified or small or diminished, this formula gives the magnification and it is equal to h dash by h, where h dash is the height of the image and h is the height of the object, is equal to v by u. Magnification, which is denoted by small m, equals to h dash by h, where h dash is the height of the object and h dash is the height of the image and h is the height of the object, is equal to v by u. Here also, if you see, this is plus. In the case of mirror, The mirror formula, I'll just write it here so you can just comparative, you can just see it. So mirror formula was, if you recollect, it was 1 upon f is equal to 1 upon v plus 1 upon u. And magnification was m is equal to h dash by h minus v by u. So can you see the difference? For magnification in mirror formula we had minus, here we had positive plus. There in the case of mirror formula we have plus 1 by u, here it is minus 1 by u. So this is the difference between lens formula and mirrors formula. I hope it's clear to you. Now I'll talk to you about the power of the lens. What does it mean? Power of lens. Which sign we are supposed to give for the convex and concave lens. So now I'll explain about the power of a lens. The ability of divergence or convergence of light rays depends on the focal length of the lens. A convex lens of small focal length will focus the light rays closer to the optical center, so it will have higher degree, or the angle of convergence will be more. Same thing happens with concave lens. A concave lens of small or short focal length will have larger angle of divergence. So the power is expressed in terms of focal length, the degree of divergence or convergence of the lens or the rays depends upon the focal length, and it is expressed in power. So power is equal to 1 upon f, where f is in meter. So if f is in meter, it will be 1 upon f or 100 upon f when f is in centimeter. So we have power is equal to 1 upon f if focal length is in meter, or 100 upon f if focal length is given in centimeters. So this is about the power. You've seen the lenses or the specs, few of you must be using. So we have plus and minus powers. Because P is equal to 1 upon f, so it depends on the focal length. Now you're related to the focal length of concave and convex lenses. For convex lenses, the power is in the focal length is always positive. So when we have the positive power of any lens, it means it's a convex lens. You also know that concave lenses has negative, this is positive, negative focal length. So the power also will be negative. So if I'm talking about someone is using the specs of say plus 2D, D is the SI unit of power and it is diopter. This is the SI unit of power. SI unit of power of lenses. So when the power is positive, it means we are talking about convex lenses. If the power is negative, then it is concave lens. So if someone is wearing the lens of plus 2D, it means it is using convex lens, that is 1, and 2D. D is for the diopter here. What will be the focal length of the lenses which he is using or she is using? We are going to talk about it in detail when we are going to take a few numerical problems. So what did we discuss today? The sign convention, which actually is the rules are the same as for sign convention of distances. I've told you that if you could just relate to the sign convention for mirrors, it's almost the same except one change, that in the cases of lenses, we are going to take the measurements from optical center of the lens. Rest remains the same. Then we spoke about the lens formula, that is 1 upon f is equal to 1 upon v minus 1 upon u. And the magnification formula is h dash by h is equal to plus v by u. I've given you the comparison with the mirror formula as well. Then we spoke about the power of a lens, that the degree of divergence or convergence of lenses is expressed in the terms of power. Power is equal to 1 upon f if f is in meter, or 100 upon f when f is in centimeters. Then I told you, because convex lenses they have positive f, so naturally the power also will have positive sign. Concave lenses, because they have the negative f, so that is why the power is also negative. The SI unit of power is diopter, which is denoted by capital D. So that's all for the day today. Stay healthy, stay safe, and a very big thank you to you all. Please subscribe, like, and share my channel if you like the content. Thank you and bye-bye.